In question 1.31, we are asked to calculate the force on an alpha particle, which is nothing but a helium nucleus, right? So it's nothing but a helium nucleus. The force on an alpha particle passing a gold atomic nucleus at a distance of 0.003 angstroms. So the alpha particle is passing through a gold, AU stands for gold, atomic nucleus. And the gold atomic nucleus has 79 protons. So that's the positive charge inside the nucleus. So this force is nothing but a simple electrostatic force, which can be computed as 1 over 4 pi epsilon naught times Q1, Q2 over d squared, where d is the distance between two charged particles. Q1 and Q2 are the charges of the two particles. So the charge of the alpha particle would be 2 units of positive charge times the unit of charge. What exactly is the magnitude of charge? It's 1.6 into 10 to the power negative 19. We can have 1.602 for more accuracy. Now this is the charge of the alpha particle, right? And the charge of the gold nucleus would be 79 units of charge, and the magnitude of charge is going to be 90. So the units are in coulombs, so it's important to write the units. And I have a positive sign, I don't have a negative sign because we're dealing with positive charges. If it were to be an electron, the charge of an electron is going to be of the same magnitude, but of a negative sign. Divided by, we have d squared, which is 0.003 times 10 to the negative 10 meters whole squared. And now I'm going to multiply the whole thing. We need to multiply by this factor, right? 1 over 4 pi epsilon naught. So the magnitude of that is 9 into 10 to the power 9. And the units are Newton meter squared per coulomb squared. Those are the units. So now if we were to maybe cancel out the units, the meter squared from here and the meter squared gets canceled. We have coulomb, and a coulomb to the power negative 2, that gets canceled. So we end up with newtons, which is the right unit. And now we need to compute the values. So if I were to compute this, it would be multiplied by, now I'm going to gather all the powers of 10 together. 9, 10 plus 10. This is coming from the denominator. And so the negative 19, 10, and 9 gets canceled out. And so I will have this term basically becomes 10 to the power negative 19 plus 10, which is 10 to the power negative 9. And the whole value has the units of newtons. So if I were to apply the 10 to the negative 9, I would have something like 4.05 into 10 to the power 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the power negative 9 Newton. So this would be 0.405 Newton. So that would be the answer.